Hello, Professor. My name is Hardik Kumar, and this is my presentation for Comp3132 Assignment 2. So, in this assignment, we had to make a multi classification model, a sequential model, to basically classify all the different types of flowers in the iris dataset. And we were provided with a file called, let me show you. So we were provided with this file called assignment2 underscore iris.csv, and we had to basically use the iris dataset inside that CSV file to work with the iris dataset instead of importing it from Keras. So in this line of code, we are basically finding the path of CSV file and saving it in a variable called file name. That we can easily do by right clicking on the file and copying its path. After that, it says file found on content slash drive slash my drive slash collab notebooks here. In the next question, it says read the content of the iris.csv file and save it in a variable named iris. That I did here. Next, it says uh, show the first 5 rows of the data frame, which we can do using dot head, and it's here. So as you can see in the species column, which says the species of the flower. In the next question, it says to convert the last column's string to integers. And here we have done exactly that. So ilog is basically used to uh, slice a data frame. This is similar to slicing in a numpy array. We just need to use the .ilog prefix. Next, there is check the first 5 elements of the iris dataset once again. So if we check it, all the setosa here have been turned into zeros. Next, it says select the first 4 columns of the data frame as data and call it X. We've done that here. And next it says select the last column as the label and call it Y. And we also done that here. Next we have it is time to split the data X and label Y into training and testing segments and call them parts X underscore train, X underscore test, etc. It says split the data and label into training and testing segments while the size of test data is 20% and use random state 123 to make all the answers similar in the whole class. I've done that here, and in the next question it says check the first 5 rows of X train, X test, and Y train, Y test. For that we can just use the head function, and it's all here. As you can see. And in the next question, it says check the length of the X train and X test. If numbers are 120 and 30, you're good. And as we can see, X train is 120 and X test is 30. In the next question, it says convert Y underscore train and Y underscore test from categorical to one hot encoded values and call them one hot train labels and one hot test labels respectively. So we have done that here, and we've converted both of them into one hot encoded values. In the Next question, we have defined a sequential model that contains three dense layers uh, containing these specifications. So I have done that here. In the first layer, uh, I have included the value activation function. Also in the second layer, I've done the same. In the last layer, I have the softmax function. And in the next question, it says compile your model using RMS prop optimizer, an appropriate loss function, and accuracy for your metrics. So in this, I have used the RMS prop optimizer, the categorical entropy loss function, which is basically used to categorize, which is basically used in the data sets which have categories like our iris dataset. And metrics accuracy is just used to measure the accuracy of our model. In the next line of code, I have trained my model uh, with a batch size of 10 and like 20 epochs, which means it trains 20 times on the dataset. Next, I have it says calculate the result evaluating X test in one hot test label and report on the accuracy of your model. So my model is 96.67% accurate. In the next question, we have repeat all we have done in 6a with the following parameters. In the first and second hidden layers, use 10 hidden units and value activation function. That's the same. And for output layer, we need to use 3. That's also kind of the same. So I've done that here. And 9b says use the same settings as for 6b. I've done that here. Use the RMS prop optimizer and categorical cross entropy loss function. And my matrix is set to accuracy. And the last question, not the last question, but like 9c says please train your model using uh, epoch 4 and batch 10. So we have to make 10 batches of the data and train it 4 times on the data. After doing that, says calculate the result evaluating the X test and one hot test underscore label and report on the accuracy of your model. So my model is 50% accurate, not that good, I guess. And now we have question 10, which says how does the number of layers or hidden units could impact the accuracy of our model. So if we have more layers on neurons, it just means that the model has higher capacity for learning. But it does pose a risk of overfitting if we do that. And if we have less layers, our model is simple, but also less accurate. We have to find the right balance of the number of layers we need. Second question which says, do we always suffer from overfitting? And I would like to say no. Overfitting happens if the model is too complex for the data, and uh, if the data set is small and we have excessive neurons or layers, that increases the risk of overfitting. Overfitting means overtraining. And the next question is, how can we detect overfitting? The way to detect that is uh, the training accuracy will increase, but the test accuracy stops improving or drops sometimes. Also, there is a clear gap between training and validation performance. That's how you know your model is overfitting. And the last question is, how can we reduce overfitting? So, don't a few ways to stop overfitting is to like stop training the uh, model early, and when you notice the validation and the training gap, the gap between those two increase, just stop training. And we can also use regularization. uh, Also we can use data augmentation, which increases the dataset variability. And one more thing, last thing but not least, we can reduce the number of layers our model has. That's how we reduce overfitting. And the last question, it says use different settings than the ones we chosen. 9 question, change each of the following ones: optimize the number of layers, hidden units, number of epochs, and batch size. So here I have done that. uh, I have changed the okay, so instead of using the RMS prop optimizer, I have used Atom, which is kind of faster than RMS prop. And also I am training it 4 times and my batch size is 10. And it says hidden units, number of epochs, batch size. So that resulted into like 43% test accuracy, which is not that good, I know, but that's what my result is. So that's it for my presentation for assignment 2. Thank you.